So I'm going to go ahead and record this for those that are not here. First of all, before we get started, I'd like to make a real quick announcement, and that is, well, there's a couple of different announcements here, guys. So the first one is, whenever you logged in today, you should have seen where you had an announcement pop up. If you have not seen it before, I'm pulling it up now. So this is the announcement right here. So what you should have done was click on this, and all you're doing is filling out this liability form. So for this class, it would have been EET 100. So that would be also under, whenever you pick it, it'd be picking Allison Bush, your day's date, your name, the email address, and your signature. Okay. And all this is just a waiver, that college isn't responsible if anything happens like that kind of stuff. The second thing is a little bit different as well. So not only do you need to fill out this form, but you need to make sure you're paid up for the classes, because this week they are dropping students that are unpaid. So please, guys, if you have not finished your process to pay, or you need any help, please contact Financial Aid Office. They will help you with whatever you need help with. So there is that. Any questions on those, guys?
No, ma'am.
All right. So like I said, before you come to class, you need to make sure that waiver is signed. It's going to send a virtual copy to me, as well as to the VP of the college, Dr. Crawford. Excuse me. But that has to be signed before y'all come on campus. It's one of those big things they're trying to push for right now. So go ahead and just knock that out. It shouldn't take you too long. Okay, so let's take a look at these tables and just kind of discuss what they are and how you would solve it. So first of all, what did we talk about on last Wednesday?
We talk about scientific calculation and engineering calculation.
Scientific and engineering notations, as well as the metric prefixes. So those of you at home, make sure you have this maybe open on a second window. You don't have to have a separate monitor. You just need to have some window somewhere that you can kind of start working on memorizing these. But for table 1, the first thing they want you to do is express the number in scientific notation. What is scientific notation? So in front of that decimal, you have to have a number between 1 and 10. How many numbers can be in front of that decimal? I'm sorry, it has to be between 1 and 9.
1, 3.
You can only have one number in front of the decimal if it's scientific. And whenever you're counting up the moves, you have to count every time you move it. So for the first one, let me pull it up on the, I'm going to share a blank white board on here. So the first one, we have What is the scientific notation of that?
1.2 times 10 to the fourth.
1.2 times 10 to the fourth. What's the engineering?
It would be 12.3 times 10 to the third. Oh, sorry. I was looking at the other one. Wouldn't it be just 12.0?
You don't even have to put a decimal with it. It'd be just 12 times 10 to the what?
To the third.
To the third. So then what is my metric prefix?
Would it be just 12? I think.
Metric
12,
prefix, what it's asking for is what is the shorthand version of what I would call this? So that goes back to the kilo, mega, giga, tera, milli, micro, nano, pico. So where are we at with this one? We should have kilo. Because kilo is times 10 to the positive 3. Does that all make sense, guys?
Yes, ma'am.
All right, so what if I was to give you the number? See if I can make this a little more challenging right now, quick. I'll just do the second one then. So we have 3,300,000,000 Sorry, I gotta fit another couple of zeros in there. So what is the scientific notation for number 2? That's 3,300,000,000.
Would it be 3.3 times 10 to the ninth?
That it would be. All right, for engineering notation, is it going to be different or is it going to be the same?
It would be different, I think.
Nope, it'd be the same because we're moving by powers of 3, right?
Oh, okay.
So it'd be 3.3 times 10 to the ninth. So what is my metric prefix for 10 to the ninth? Giga. Everybody agree on giga?
Yes, ma'am.
So you gotta be real careful with these and the way you're moving that decimal. Y'all want to take a few minutes and try some of these on your own? Because I'll let you go ahead and try a few.
Sure.
It's a good question. We'll be going over that after this first test. Mm-hmm. There we go. So I'm going to give everybody just another minute or two to work on a few of these. That way, if y'all have any major questions, we can go over them now instead of later, essentially. All right, so looking at the third one down, we have 45 million. First of all, what is my scientific notation?
.5 times 10 to the 10th power.
Is 4.5 times 10 to the 10th. What's the engineering notation? $45? 45 times 10 to the 9th. Why is it 45 10 to the 9th? You're
Because you
following?
had to have two numbers in front of the decimal.
You have to have at least, you're moving by powers of 3, so you have 3, 6, 9. Let me switch this back over to where this was. All right, so you have powers of movements of 3. So you have 3, 6, 9 spaces that we've rolled up. So do I have another set of numbers in front of these two? Answer is no. So I'll take the last two right here. That's going to be part of my engineering prefix. And then I'm going to tally up how many times I've moved that decimal to make it 45, which would mean that it's now 45 times 10 to the ninth. Again, that is engineering notation. You're moving by powers of 3. Does it make sense? So what is my metric prefix on this one?
Be giga.
It would be giga. All right, so again, start working on that table at the top, guys. You do need to start getting this memorized because you use it every time you're in one of our classes. So go ahead and start working on getting it memorized. All right, so is there anyone y'all want to look at specifically or have questions about for this particular one? Not for the positives? All right, then let's move on to the negative powers of 10. Like I said, y'all can do a lot of this kind of work at home. I'm just trying to help make sure that y'all know what you need to do with this. That way you can ask questions now instead of looking at this like I'm crazy later. Okay. So looking at the first one, that's 0.015. What is its scientific run here? How do I put that in scientific notation?
Move the first one. We're doing the
Yes.
first one correct. You move the decimal back twice between 1 and 5. Be 1.5 times 10 to the. What would it be? 10 to the negative 2, wouldn't it?
Yes, it would. All right, so this one would be 15 1.5 times 10 to the negative 2. What is its engineering notation? What do y'all think? What is the engineering notation?
Be 15 times 10 to the negative 3.
It would be 10 to the negative 3. 15, 10 to the negative 3 is correct. Y'all see what I'm trying to, y'all feeling all right about that?
Yes, ma'am.
All right, so what about this guy right here?
That wouldn't be 1 times 10 to the negative 7.
So you got 3, 6. So yes, it is 1 10 to the negative 7. So what is its engineering notation?
Wouldn't it be the same, maybe?
So let me kind of share a whiteboard here.
I'm confused on this one.
I understand. So what you have is point, and then you have 6 zeros. And you have a 1. So what do we break them off into groups of? Make it visually easy for us. Break them into groups of 3, right? It helps to break it down.
That's good.
So you break this into 3. Here's another 3. So I've moved my decimal 6 times so far. Have I got a number in front of that decimal yet?
No.
All right. So now I come to my 1. And what is always understood about any number we use is that there's always what? Is that there's always zeros that are just merely placeholders. They have no meaning until you do what? They have no meaning until I make them part of a number. So in this case, you would end up with 100 times 10 to the negative 9. Does everybody see what I just did?
Yes, ma'am. I see now.
Anybody else got questions on that one? All right, then let's take a look at a few more of these. I'm going to let y'all loose with them for a few minutes, and then we'll talk about any that you had questions about. Hmm? Yep. right, so if y'all got any questions on any of these so far? You want just another minute to work with them before we go over them?
No, man, I'm good.
Okay, so is there one y'all want to go over? Because there's a couple I'd like to kind of go over. So first of all, this one right here. What is the scientific notation for this one?
That'd be 9 times 10 to the 10th power. Negative
9 times 10 to the 10th power, yes. That is correct. It is 9 times 10 to the
Negative 10.
negative
Correct.
10 power. Okay. What is its engineering notation? Anybody want to take a guess?
Would be 900 times 10 to the negative 12th power.
That it would. That it would. Any questions on that one, guys? So what is its metric prefix if it's 10 to the negative 12?
Pico.
It'd be pico. Very good. So what about this last one, 0.0047? What's my scientific notation?
4.7 times 10 to the negative 3.
4.7 times 10 to the negative 3. That is correct. What is my engineering notation?
47 times 10 to the negative 4.
No. What do we move in powers of?
3. So it'd be 4.
It'd still be 4.7 10 to the negative 3 because
Correct.
we're moving in that power of 3. Okay. That's kind of why I wanted to clarify that particular one, is because that one's very easily seen as, well, here's my first 3. After that, I don't have to worry about it. It's going to translate across both sets. Now then, what is the metric prefix for negative 3?
Milli.
It is milli. Okay. So guys, I'm going to let y'all kind of have a little free reign and run with this one for table 3 for just a minute, and then we'll talk about a couple of them. Just kind of let y'all have a little more practice before we move on for a bit to something else. What's up? No, the rest of them are online. You're fine. All right, guys, so let's take a look at a few of these. So one of the ones I want to look at is this guy right here, this 124V. Now, if you had looked at this table at all, V stands for volt, and we'll get into what exactly voltage is and all that after we do test one on, I believe we need to get that knocked out on Wednesday. So 124 volts. So scientific notation, what would that be?
Would that be 1.24 times 10 to the second?
It would be. What about my engineering notation?
Wouldn't that be 12.4 times 10 to the... I'm not sure.
Okay, so with this guy, what he is he's just going to be a whole number. He has no engineering notation because there's no way I can put him in a power of 3 without ending up in either 0.124, which that's not going to work because I don't have a number in front of that decimal, or I get 124,000 millivolts. That doesn't work either. You have to have it as only 3 numbers, not 6. So what this would end up being is just 124, and it's 124 volts. That's all it is. Does that make sense?
So under engineering notation, it would just be 124?
Yes.
Okay.
So if we go back and look up at the powers chart, there is no prefix for the whole number, guys. Everybody see that? There's no prefix for the whole number. So that 124 falls here. So I'd have 10 to the 0, which basically means it's just canceled out. So it's just 124 volts. Questions on that, guys?
Okay.
Okay. So looking at table 4, because I'm pretty sure y'all kind of get where I'm going with that one. So looking at this one on table 4. So when I said multiply, what do we do with our exponents? Multiplied means add, divide means subtract. So when I have milli multiplied by milli, so that's -3 plus -3, what do I get? -6, what's the prefix?
Micro.
That is micro. Okay. So when I go to, let's say milli multiplied by mega. So first of all, what is milli?
-3.
What is mega?
6.
So -3 plus 6 gives me what?
Kilo.
Gives you kilo. Gives you 3. Okay. So let's look at the divided bys. So here we have pico divided by pico. And I said when we do divide, we what?
Subtract.
You subtract those exponents. So what is the thing that you need to make sure you don't do? It's a basic mathematics rule, is that you cannot what? Not quite. So you cannot subtract a what? It is a hard and fast math rule. You're not allowed to subtract a negative. So right here we have negative 12 minus negative 12. Will that fly?
Yeah.
So what you end up doing is adding positive 12, which basically means this is going to be a metric unit of 0. There is no metric unit for that one. Does that make sense?
Yes. So in the answer, would you just write 0?
Yes.
Okay.
That or whole number, something along the lines lets me know that you understand that that is not going to have a prefix.
Okay.
So what about milli divided by micro? First of all, what is milli?
-3.
What is micro?
-6.
So negative 3 minus negative 6, what do I end up getting? You should get a positive 3 or kilo. Okay. All right, so let's take a short break, and when we come back, we'll look at these and how to solve them. So, looking at number 1, we have 6.3 times 10 squared divided by 4.2 times 10 to the negative 1. Okay. So what would be the first step I would need to follow in solving this? So what would be my first step in solving this, guys? What do y'all think?
You subtract the exponents, or I have no idea. So I think it's some of the exponents.
All right, so let me pull up the whiteboard again. So we start off with 6.3 times 10 to the second, and we're dividing by 4.2 times 10 to the negative 1. So what I need to do is bring my 6.3 down and divide it by 4.2. Bring this on over here. All right. And then I'm going to bring down my 10 to the second. And I'm going to subtract 10 to the negative 1. So first of all, what is 6.3 divided by 4.2?
1.5.
1.5, okay. To, 2 minus negative 1, what do I get?
3.
You get 3. So that'd be 10 to the third. So combine it together, you end up with 1.5 times 10 to the third. Does everybody see how I did that?
Yes, ma'am. It's not as hard as I thought it was going to be.
Generally isn't. All right, so I'm going to drag this back over here and give y'all back this. Okay, so for the second one, y'all want to work that on your own for just a minute, and then we'll come back and talk answers? So by the way, 1.5 times 10 to the third, is that scientific or engineering notation, or is it both?
It's scientific.
It's actually both. It is scientific
Oh,
and
okay, yeah.
engineering notation, 10 to the third.
Yeah, you're right.
So 1.5, 10 to the third. I wish I could actually write this on here, but it's not letting me. So looking at number 2, has anybody come up with an answer, or y'all want just a minute to work with it?
I need a minute.
All right, I'll let y'all have just a minute, and then we'll go over it. By the way, quick question for everybody here right now. Has everybody done their math quizzes?
I just have the last one left, Miss Vish.
Okay, y'all need to make sure you get those done.
Okay.
Because they are worth, I believe, 25% of your grade.
Yes.
So you need to go ahead and make sure that those are done. Not to mention the questions on those quizzes tend to be what's on the test. All right, so what is number 2? Hmm? 2 10 to the 5th. Does everybody agree with that?
Yes, ma'am.
It is 2 times 10 to the 5th. What about so looking at number 3, this time we're multiplying instead of dividing, so what does that mean?
We're adding.
We're adding exponents. So you, again, just like we did with divide, you're going to pull out your numbers, and then you pull your exponents separately. You add your exponents, you multiply your whole numbers. So 4.8 and 10 times 3, and then 10 to the 5th minus, 10 to the 5th plus negative 1, which would be the same as subtracting 1. So what is 4.8 times 3? Close. So when you multiply 4.8, actually, right, it'd be 14.4. I don't know why I'm seeing 14.3 right now. 14.4 times 10 to the 4th. However, is that in scientific or engineering notation? The answer is neither, right?
Correct.
So 14.4 to get that into engineering notation or scientific notation. So let's pull up the whiteboard so I can do some demonstration here. So you end up with 14.4 times 10 to the 4th. So there's a couple of different ways you can play this. If I move my decimal forward one place, I get 1.44 times 10 to the 3rd. I'm sorry, times 10 to the 5th. Excuse me. 1.44 times 10 to the 5th. However, if I turn around and instead say move it back 1, I get, 144 times 10 to the 3rd. So why could I not move it forward? So if I had 4, move it forward 1 for 5, and then move it forward 1 for 6, why would that not work for being in correct notation? What? You have to have a number in front of the decimal. That is correct. So you must have a number in front of that decimal, guys. So does everybody kind of see what I did?
Yes, ma'am.
Any questions? All right, so let's let y'all work on number 4, and then we'll all work together for number 5. So I'll give y'all just a few minutes to work on number 4. right, so for number 4, what is my scientific notation for number 4?
$32 times 10 to the 7th.
That's not, okay. So again, going back to the whiteboard here. You have 8 times 10 to the 3rd multiplied by 4 times 10 to the 2nd. So 8 times 4, and then we have 10 to the 3rd plus 10 to the 2nd.
I'm sorry, I added the exponents wrong.
So 8 times 4 is 32, so y'all were fine with that. And then 3 plus 2 is 5, so you end up with 10 to the 5th. However, 32 10 to the 5th is not scientific or engineering notation, is it?
It's not.
So my decimal, we always understand, is at the back end of any number we've got written. So we move it forward 1 place. We should end up with 3.2 times 10 to the 6th. Does it make sense?
Yes, ma'am.
All right. So looking at the last one, guys, and I think I'll just leave this on the whiteboard. I'll write it down real quick. You have all right, now that I've got that written down. So where would I start on a problem like this?
Would you work on the left side of the division, and then you'll do the right side on its own too, and then you'll come in the middle from dividing?
I'm glad you asked that question because this is where everybody always trips up with this particular problem. That's why I kind of try and work it for everybody. What you're going to do is you're going to start off with these two numbers, and then you're going to divide by this and then multiply by this. So you literally work this from left to right. You don't do your multiplications and then divide. You have to multiply, divide, multiply.
Oh, okay.
All right. So we start off with 28 times 3.5. And then 10 to the 9th plus 3. So what is 28 times 3.5?
98.
Is 98. And then bring down my exponent, excuse me. You have 10 to the 9th plus 10 to the 3rd. That gives you 10 to the 12th. So then I'm going to take my 98 and I'm going to divide by 8. So you bring down 98 divided by 8. Which would give me what? One point.
1.2? No, it's 8, 9.2.
You should end up with 12.25.
I got 12.25.
And then we have 10 to the 12th minus negative 6, which gives us what? You should end up with times 10 to the 18th. So we cannot subtract a what?
Negative.
Can't subtract a negative. So the next thing I'm going to bring down is I'm going to bring that 12.25 and multiplying it by 4. So far we've gotten rid of this guy, and this guy. We're down to that 4 times 10, times 10 to the 1, so 12.25 times 4. And then we've got 10 to the 18th plus 1, 10 to the 1. So what is 12.25 times 4?
49.
49. 10 to the 18th plus 10 to the 1 means I'm doing times 10 to the 19th. Is that scientific or engineering notation? Both or neither? The answer is neither. So what I'm going to have to do is one of two ways. If I want to put it in scientific notation, I'll move my decimal place forward once, and I will get 4.9 times 10 to the 20th. However, if I move my decimal place back one, I would end up with 490 times 10 to the 18th. Does everybody see what I did?
Yes, ma'am.
Does anybody have any questions on this? Okay. So that's all we're going to do with this particular worksheet for right now. I'm going to all right, so if y'all don't have any questions on these, let's look at so this is something that y'all should be getting into, guys. If nothing else, then just because it'll help you with working some of these. Because all this is the same stuff we've been doing today. This is out on Blackboard. If you look under content, you look under chapter 4 or module 4, whatever you want to call it. You should see where these worksheets are posted out there. This is Powers of 10 PDF. It has all this great practice for y'all. One of the best things I can think of for y'all to practice, especially over the next day or two, are these. We'll do a few more of these here in a few minutes. I might let y'all have a little time to kind of work through either the evens or the odds, depending upon what y'all want to do. But this will give you really great practice. Now, I know a lot of y'all are wondering why we're worrying so much about multiplication and division of powers and roots. And that's because once we really start into electricity, that's where all of this becomes relevant. And I won't go into any more depth because I don't want to kind of blow y'all's heads off, blow your minds out right now, because this is really one of the most base things we do. Excuse me, I can't talk. In everything we do, we use these numbers and these equations. So what I'm wanting y'all to do for the next few minutes is let's do this column 1 through 5 and then 11 through 15. I'll give y'all just a few minutes to work on those, and then we'll come back and we'll talk about what we did. Sound good?
Yes, well, Ms. Bush, I have a question. When is the first test?
I was thinking about doing it Wednesday and going ahead and getting that knocked out so we can move on into other fun stuff.
Okay.
Is this coming Wednesday?
What?
This coming Wednesday?
Yes, because we've covered everything we need to. We're doing a little bit of review today, so I was thinking test Wednesday just to go ahead and get that knocked out.
Okay, thank you.
The sooner we get that done, the sooner we can move on to stuff that's hands-on and fun.
Great. Miss Bush.
Yes.
I was having trouble with the internet. I just fixed it. When are you gonna post this video? You're gonna
I'll be
post it
posting
today?
it this afternoon.
Okay, great. Thank you. I would like to check at it. Thank you.
Not a problem. Like I said, I'm going to give y'all just a few minutes to work on the questions to the left. We'll kind of talk our way through them here in just a minute. Guys, y'all go ahead and continue working, but I'm going to make one other announcement. And that's the fact that if you want to, you can be on campus for classes from here till the end of the semester. The reason I say that is because I know some people might have a harder time learning from home, but we are holding classes on campus as well. So we'll be doing labs and stuff like that too. So we'll still be holding virtual lectures. But if you are going to be on campus, guys, you do have to sign the waiver for each class you take.
Okay, thank you.
You can get to it very easily by going under announcements. Or when the announcement pops up, just follow the link. All right, is everybody done with these? Or do y'all still need a minute? So I did this just to kind of give us a little bit of a place to work on these. Have y'all got all these ready, or y'all still working on them? Okay, so number one, so that's 25 times 10 to the 0, multiplied by 2 times 10 to the third. So what should my answer be for number one? So 25 times 2 is 50. Ten to the 0 plus 10 to the third is 10 to the third. For scientific notation, you would just move it forward one place and you'd end up with 5 times 10 to the fourth. So for number 2, we have 100 times 10 to the negative 3 times 4 times 10 to the negative 4. Now, just so I don't end up with giant numbers, what I would actually do with this one, guys, just to make it a little easier and be less moving of the decimal. To get to negative 3, I had to move it this way 3 times. So if I move it back 2, I'd end up with 1 times 10 to the negative 1. Be a little bit easier to multiply. So 1 times 4 is 4. And we have times 10 to the negative 5. That make sense to y'all?
Yes, ma'am.
Yes, ma'am. It's lots of easy.
Be a lot easier doing that than having to do 20 million other steps.
That's correct.
And then to get it into engineering notation, you would just have to move it forward one more place, and you get 40 times 10 to the negative 6. But this is simplest notation. So just like whenever you were working with decimals, or you're working with any number, simplify first. Same with fractions, right? If you simplify the problem first and make it the easiest problem you can possibly make it, always take that second look at any problem like this, because you can find ways not to so much cheat, but to make it easier for you to manipulate the numbers and get what you want. So for number 3, I have 22 times 10 to the fourth multiplied by 3.3 times 10 to the second. So one way I could do this is go ahead and multiply these out. And I believe I'd get 66, 72. Is 72.6, excuse me. You get 72.6 times 10 to the 6, and that would work. If you're doing it in scientific notation, you would just move your place one more forward to get its scientific notation. It'd be 7.26 times 10 to the 7th. Okay. So number 4. Do I really need to worry about this 0 after this, guys? The answer is no. Just kind of, I don't know why The weirdest thing to me is when people put a 0 in front of a decimal place, but even weirder is when you put a 0 after a decimal place that is not necessary. I don't know why people do it. It's just strange to me. Then you just end up adding extra writing to whatever you're doing. So we end up with 4.7 times 2, which I believe is 9.4. We have -6 plus -3, which would give me times 10 to the -9. And then number 5, before we get to division, I have 15 times, ooh, that's not a number I want to mess with. That looks like a pain in the rear. So let's simplify this number from 300. Let's move it back this way 2 places. So we end up with 3 times 10 to the -3. So then when I multiply 15 times 3, I get 45. 2 plus -3 means I'm going to be multiplying that times 10 to the -1. But that won't do, so we'll have to move my decimal place back 1 and get 4.5 times 10 to the 0. .5 times 10 to the 0. Does everybody see how I did that? And kind of understand why I did it the way I did? Any questions on this, guys?
So for the exam, it's gonna be the same thing like this. If we have the answer, just we're gonna answer it like this. That's all, right?
You're gonna be doing fractions, decimals, ratios and proportions, powers and roots.
But for example, like this, the one we did now, this is the answer 1, 2, 3. This is the answer you did, right?
Yes.
Okay.
It's all going to be multiple choice questions anyway.
Okay.
But yes, this is very similar to what you'll be doing on your test.
Okay, great. Thank you.
Okay. So that's 1 through 5. Let's switch to a different ink color. Go blue. All right, so playing division. Let's see what we can do to make these a little bit easier. Now for number 11, there's a couple of different ways I can modify this. The very first one I'd rather do is move that 2.5 into 25. So this would mean that I'd move it back one more place. I would get 25 times 10 to the -5. So I have 25 times 10 to the -5. So 100 divided by 25 is 4. -6 minus -5 means I'm going to have 4 times 10 to the -1. Does everybody see how I got that?
No, ma'am. Did that 100, we move it forward or something? No?
Yes, I moved my decimal place one more place backwards. So so this goes back to the when in doubt, write it out. So 25, this was 2.5 times 10 to the -4. Correct?
Yes, ma'am.
So that means that I moved the decimal place this way 4 times. So there's one of two ways I could deal with moving into a whole number that I would be more comfortable dividing with. Something that would be close to what I'm actually dealing with. So one of those is I can move it back and make it into a 0.25 negative 3, or I'll move it forward one place to get 25 times 10 to the negative 5. Now then, division means that I'm subtracting my exponents. So when I get negative 6 and negative 5, minus, you cannot subtract a negative. That is a no-go. So what you do is you add the positive. That's how you end up with negative 1. Does that make sense?
Yes, ma'am.
One of the oldest math rules out there, and it's one that often does get forgotten.
So the 100 you divided by 25 and make it like 4, right?
Yes, 100 divided by 25, you get 4.
Okay, great. I see.
Sorry, no, it looks like the 11 is part of this, but that is its own
Yeah, I
rule.
was wrong. Yes, yes. Thank you.
It is 4 times 10 to the negative 1. All right, for number 12, we have 5 times 10 to the 4th divided by 2.5 times 10 to the 3rd. So 5 divided by 2.5, you can just basically do this out the same way. But you should end up with 2 times 10 to the 1, or 20 is the actual number that is. Okay. Number 13. Ooh, I don't like working with 600. 600 looks like it's evil. So my decimal place is right here. If I bump it forward 1, 2 times, I end up with 6 times 10 to the 10th divided by 3 times 10 to the 6th. So 6 divided by 3, last I checked, is 2. And then we have 10 to the 10th minus 10 to the 6th, which would give me 10 to the 4th. Does that make sense to everybody?
Yes, ma'am. Question, please.
Go ahead.
Why the one like 10 to the 10th and 10 to the 6th, we do it like minus? We don't do it divide or multiply.
You are dividing because, well, you're subtracting. So anytime you see divide as part of an exponential problem, you're subtracting the exponents.
Okay.
Okay?
Okay, thank you.
But the thing you have to be careful of is you cannot subtract a negative. You have to add a positive.
That's correct, yes, ma'am.
Okay?
Thank you.
I'm trying to remember when I had to learn that for school. I feel like forever ago. For some reason, I've got an old math teacher harping in my head going, you can't subtract a negative. No, no, no.
I guess in the middle school, I guess.
I don't know when it was. I just remember having that teacher say that, and I'm going, okay. All right, so we have 12 times 10 to the negative 12 divided by 6 times 10 to the negative 10. Pretty easy for this one. So all I would need to do is 12 divided by 6, which is 2. What I gotta be careful of is the fact that I have a negative 12 and a negative 10, which means I'm subtracting a negative here. So negative 12 minus negative 10, what you have to do is add positive 10, so you end up with 10 to the negative 2. And if you hadn't figured out 15 is 0, just 0, because 1,000 divided by 1,000 is 0. No, you're right, it is 1. I'm sorry. It was either going to be a 0 or 1 for right now. Sorry, I got myself a little backwards on that. It is 1. So 1 divided by 1 is 1. No matter how many zeros you put up behind it, it's still 1. So 15 should have been the easiest. You should be able to just kind of glance and see that, but if you didn't, that's fine. Put it in your calculator, put it in anything, you're still going to get 1. Just to kind of look at it, let's look at number 19, as in, how would you simplify this so you don't end up with this number having to do something with this number? Because that's some big numbers to play with, right? Okay, so I'm going to erase all this real quick so I have some space to work here. So this one, you got to do quite a few changes on it. So what I would start off doing is turning this to bringing my decimal forward at least 2 places. So I'd end up with 20 times 10 to the 7th, and that's divided by and then I would take this and I'd bring it forward 4 places. Why? Because 20 is easily divisible by 5, not 50.
That's correct.
So moving it forward those places, I'm adding 4 numbers to my exponent. So I end up with 5 times 10 to the 6th. So when I do 20 divided by 5, I end up with 4. And I've got my times 10. I have 7 minus 6, which is times 10 to the 1, or 40. And I can arrive at the answer for 40 much faster than if I started having to work around all these zeros. Because 2,000 divided by 50,000, there is no way that's coming out right. You would have to do a lot more work. Okay. Does everybody have any questions about multiplying and dividing exponential formations? I guess I'd like to follow them. Does everybody feel pretty comfortable doing this?
Yes, ma'am.
Okay. All right, so I'm going to go ahead and erase all this. Let's see. Is everybody feeling pretty good about working with powers and roots?
Yes,
Okay. Is there anything y'all want to work on with ratios, proportions, fractions, decimals? Because if not, we're going to take about a 10-minute break, and then we'll come back and work a few of these, just so y'all can get used to moving that decimal visually. Okay? All right, so looking at these problems right here, so what you are needing to do is being able to move between the different notations. So let me pull this over like I did the other one. This way I can expand it as well. Okay, so looking at this one, guys, the main thing you need to do is be able to move these back and forth between the different notations. So let me go ahead and put those up for you. So here you have the 0 or the whole numbers, kilo, mega, giga, tera, milli, micro, nano, and pico. So for the first one, for example, we are moving from milliamps to microamps. So what kind of difference will that make in my number? It's going to be a bigger number. So what I should end up with eventually is 22,000. Does everybody see that? All right, so what would y'all say would be, so what about number 2? If I'm moving from microamps to milliamps, how is that number going to change? I should end up with 3.5 milliamps. So I'm going to give y'all a few minutes to work the next 8. We'll go down to number 10, and then we'll go over the answers for them one by one. Everybody good? So what should I have for number 3?
Miss Bush,
Yes.
I know we're gonna transfer to kilo, right? But the other one is what? This I don't know the
This is mega.
mega. Okay.
So that's this guy right here. So going from
Okay.
mega to kilo, I'm going to end up
Okay.
with 4,700.
100. Okay.
And then again, we're going from mega to kilo, and this one should end up just giving
47.
me 47 kilo.
47.
So this one's moving from kilo to mega. What would I end up with? Should end up with 1.51 mega. And then we're going back from mega to kilo. All right, so number 7. This is a little bit different. We're moving from micro to nano. What are my numbers for number 7? What do y'all think? You should end up with 300 and
3,300.
330,000. Now number 8, we're moving from milli to micro. So I should end up with 40,000 on this one. This one I'm moving from micro to milli, which would give me a value of 0.5. And then this one is moving from mega to giga, which should give me 1.5 gigahertz. You'll see what I'm trying to help y'all learn to do?
Yes, ma'am.
So I'm going to let y'all have the last 30 minutes of class to work some of the different problems on these worksheets. That way we can do a little bit of Q&A if anybody has any major questions crop up that y'all don't understand something. But don't forget, guys, your first test is Wednesday.